Hey, Josh.
Hey, Brad.
Thanks so much for coming in.
Yeah, thank you. It's a pleasure. It's a pleasure.
Yeah. So tell us, we'll just set the stage. Tell us a little bit about Aori, what you guys are building, and then we'll dive into it.
Yeah, absolutely. So Aori is a cross-chain and same-chain intense protocol built on top of LayerZero. So Aori at a very high level has smart contracts deployed onto every chain where a user can simply make a deposit and a solver on whatever chain the user specifies can fill that order instantaneously. It's an incredibly fast protocol. It allows for pricing of cross-chain bridges, cross-chain swaps, and even in the future things like derivatives as well, all through it. And under the hood uses LayerZero for all of the settlements. So instead of using an oracle that's centralized or some kind of a convoluted TEE, we allow for the solvers and the users to directly specify, what's this order, how am I going to fill it, and then allow the solver to settle and rebalance whatever they choose to. So it kind of simplifies the entire flow of an intent, much more so than exists today.
Awesome. Yeah. And just quickly tell us your background of the team.
Yep.
What made you start to build it?
Yeah, so I was in the dark land known as market making before, which kind of gets a very bad rep, and for a pretty good reason in many cases. But I was a market maker both of spot tokens on centralized exchanges, options, and then kind of got the MEV bug when doing options ARB, perps ARB between DEXs and centralized exchanges. And then that's where a lot of our co-founders and team came from. We were all traders together and thought, man, we need to fix this trading thing in DeFi. So we've spent the last year or so building out an intense platform and now use LayerZero to make that 100 times better. So very excited about that. Yeah.
Awesome. Let's dive in.
Today, you guys are all probably very familiar with O tokens and in general, mint and burn tokens between chains. And this, I think, is probably the only valid, outside of some very funky things with centralized exchanges, way to actually move tokens in a safe manner between two chains. This makes a ton of sense when you're dealing with one token like USDC or ETH and you're using something like Stargate or directly with the O tokens to move these assets between chains. It's generally, I would say the pro there is the decentralization and just how absolutely secure these things are and how easy it is and the fact that there's no fee outside of the gas. But when it comes to the timing, that's where you get into a bit of a pickle. An O token transfer, if it's between two slow chains, for example, can be a UX or a user experience of 30 seconds up to sometimes 60 seconds. And so that's generally, I would say, the con of this. And the other is that you can only go from one token to another token. These have to be the same asset between each other. And that's where the intents of today kind of come into play. Most intense platforms today are exclusively bridges, but there are some swapping platforms that allow you to do token A to token B between two chains. Generally, these will use an O token mint and burn under the hood, and that's why if you use existing aggregators, that can still be up to a 2-minute period for that. But the main problem here is if you're the solver. The solver in these cases is generally really hamstrung by whatever oracle that the platform uses for actually settling these intents after they handle the fulfillment.
So just to really, just to dumb it down.
Please, sorry.
Super early on, just to make sure everybody is on the same page.
Yeah.
So traditional bridging comes out, and this is version 1 of Stargate is basically, great, we want to transfer USDT, USDC. We put a bunch of pools in. You can think, $10 million in every chain, and you're going to add to one chain and subtract from the other. Benefit of that is everything is completely on chain. Everything, Stargate has done X, $30 billion plus now. The constraint is two things: latency, where you're waiting for the underlying finality of the source chain, or some threshold around that of its probabilistic finality, and bandwidth constraint. So if you only have 10 million in the pool, if I want to do 15 million, I can't, right? And there's usually a price curve around that. So you're constrained on the actual amount of liquidity that you can move, and you're constrained on timing. And so you said 30 to 60 seconds. I think that's even generous. Before, at least a while ago, ETH outbound was 15 block comps, which was 3 minutes and 15 seconds. And so you're talking I think today it's 29-second median transfer time between L2s, and you're getting a little bit faster. But there's that reasonable, some amount of latency, because the risk is that if you, or in all cross-chain messaging, you're mutating the destination chain based on a belief of source chain. So if I add 5 million here and I give 5 million over there, and then this chain reorgs and you no longer put in the 5 million, I already gave it to you over there. That chain's not going to reorg because this one did, right? And so that's what you're protecting against. You always have this risk of finality. And so you're really waiting to know that it's safe based on the state on the original chain to be able to do the thing on the destination. So then we get to Stargate has this model. Stargate now is about $1.2 billion in it, deployed across all of these chains. That works kind of at scale. Then you have this model of OFT. OFT is something like USDT0, Athena, WBTZ, a bunch of others. Now, the benefit of the OFT model is you don't have to have standing pools of capital. So the asset itself is the bridge, effectively, in terms of the token contract. And now I can move unlimited amounts. So like the maximum amount of the token that exists. So I could move $1 billion for literally the cost of gas, right? So in Stargate model, there's standing pools. So there might be a fee, 2 bips, 6 bips, some amount to transfer that. With an OFT, you're talking, you can move, $1 billion for, 1/100th of a penny if it's going between two extremely cheap chains. But your constraint is still the exact same thing on latency. You can't get any faster. You still have the same risk of muting the destination. So introduce intents now, and intents shift that model a little bit by taking it. You have a user says, hey, I want to transfer $1 million, $100,000, $1,000, whatever the number is, from chain A to chain B. And rather than needing to wait for that, some solver, some external party will say, I'll fill that for you. They'll give it to them immediately, take on a risk of any sort of reorg. So they're just pricing that dynamically on the fly. And then eventually, once some conditions have been met, they will go and they'll get the user's money after that. But the user gets it filled immediately. So walk us through what that looks like today.
Yeah, exactly right. Like the solver is the one who's eating finality risk, slippage risk, execution risk. That's on them. Even, for example, hedging if it's something that's not a stable coin. And so it's similar, like, I would say what it does is it allows for an open market of, competitive solvers to actually compete to provide the best price for your users. And in theory, that's really great, but if the infrastructure it's built on is not great, that leads to things like, pretty massive slippage. Like, for example, we've been monitoring quite a few intense platforms and have seen something in the range of several % of slippage in some cases, which is kind of shocking when you're thinking about O tokens, for example, which have absolutely no fees. And so that's really like the current landscape of intents is generally you'll have some centralized or decentralized oracle that actually is running their own database that's tracking all of the solver's fills and the user's deposits, and then after some amount of time, they settle all those trades in one big batch. Now, that is very bad if you're a solver, because number one, you're trusting this guy with all of your money, and you're basically praying that they're not going to rug you and take all your assets, which they very easily can. And additionally, that settle time is generally optimized for minimizing the cost to the oracle as much as possible. It's not like a Chainlink oracle where, it's getting published every 10 seconds or something like that. What's happening here is it's, sometimes hours before you end up getting repaid as a solver. And that means that's capital that the solver can't use to price more fills in the future for this user. And so that's where I think things like LayerZero and general messaging as a whole actually make the solver's life 1,000 times easier. And that's what we've been working on. I think that's probably a good segue into like what we're working on together.
Yep, absolutely.
Yeah, so the platform we're building at Aori is, and with LayerZero and using LayerZero under the hood, is we're abstracting out all of the messaging for the end user such that the user experience of a fill is they simply call deposit, and in the exact same block on the destination chain, the user has their liquidity immediately unlocked for them. The solver is the one taking on finality risk. The solver is the one pricing that liquidity, whether it's something like a bridge or it's a swap. Things like bridges, for example, through an intense platform can be, in many cases, even cheaper than like a cross-chain AMM model, which we're incredibly excited about. We're talking sub-basis point instant finality execution for users. And yeah, this is kind of what we're really excited about is the flourishing of solvers in the space. And I think like given this limitation, or given the removal of a trusted oracle and the removal of a trusted platform that's going to pay you out every several hours, it's going to open up the landscape of solving in crypto by orders of magnitude. And so this means for the end user, it's simply deposit and you get your assets back. And you have all the trustlessness and permissionlessness of the LayerZero network, and solvers have the ability to instantly be repaid in whatever asset that they chose to fill that order in. So kind of makes the whole landscape substantially easier for everyone involved.
So just to talk about like what that actually looks like, right? So right now you're saying, okay, in this model, the intense model today, I don't know that my mental model is average basis points are actually probably like 12 to 15. But do you know what like median basis points are?
Oh, it depends. If it's a bridge, it's generally in the range of 1 to 10 basis points, depending on the chain. If it's something that's a chain that has a very, very limited bridge, it can even be higher. I've seen, I won't name the L2 particularly, but there's a platform, there's an L2 where the cheapest bridge is 50 basis points for USDC and for ETH. And then cross-chain swapping today, you would be lucky if you filled an order under 10 basis points. I would say it can be up to several percent in many cases for a cross-chain swap. Just because when you're a solver and you have to fill a cross-chain swap, and it can take up to 2 minutes for that to actually fill, the amount of volatility risk that they're taking on is so massive that they have to price incredibly wide.
Yeah, so let's talk about what's actually getting priced here. In a bridge, what's happening is the solver is user puts in an order, solver fills on the other side, and the solver is taking effectively, if there's a disparity, you talk about some networks don't have easy ways to get it out to rebalance inventory back out, so then you might be some premium there. But otherwise, you basically have this 90 to a couple hours window of latency that you're exposed to, and so that's really what the solver is pricing. Is if I give my inventory here and accept inventory over there, I need to run my infrastructure and do all of that stuff, and then I need to basically eat this time value of capital over that period of time. And so the latency there directly impacts. Like if that went from 4 hours to 1 minute, your ability to quote would go down drastically.
Exponentially.
Yeah. And then even more so on swaps, because on swaps you're inheriting risk of vol of that. Like now you're like, okay, I'm giving USDC, but I'm taking banana token.
Exactly.
And like banana token, I have crazy vol, and you still have this whole period to do it. And so,
exactly right. Yeah. I would say that like to break it down into like specific buckets that a solver is pricing, like why you see the price you're getting is number one, finality risk. Number two is the slippage of the trade, which for a bridge would be 0. And then lastly, it's volatility. It's that cross-chain volatility. And then, lastly is the actual amount, how much is it going to cost me as a solver to get my assets from chain B back to chain A, which turns out in many cases to be very expensive.
So duration, vol, slippage, and then like inventory costs.
Exactly right. Yep.
Okay.
Yep.
And, okay. So that's overall. How do you view, like, in a model where now you're saying this is like near instant, right? What does that look like and how you quote? What do you view pricing basically being able to be there?
Yeah, exactly. So in current testing implementations of Aori, we are seeing sub-millisecond execution. So sub-millisecond execution means you're almost getting to as fast as the speed of light between two chains.
We didn't talk about this. Right now, how long? So we talked about this model right now between L2s, something like a 29-second median latency. What is the average latency here?
Probably median here would be about 3 minutes.
Okay.
So I'll put 3M for about 3 minutes.
Okay.
And then when it comes to cross-chain intents using LayerZero, we're talking, let's say 100 milliseconds would be the average amount of time for an execution to occur between two chains.
This gets touted as like 3 seconds a lot online.
Yeah, that's baloney. That's total. I won't use a swear word on this podcast, but yeah, not true. That's not true. Yeah, maybe you'll get really lucky if you're doing like a USDC between base and Arbitrum. You might get lucky and it'll be 3 seconds, maybe. But in reality, it's much more like 30 seconds to 3 minutes on. It would be like the middle 75%, I would say.
Okay.
Yeah, and then once you have solvers who are able to actually provide instant liquidity on these two chains without needing to attest before the swap. You cut out all latency between these chains. And then what's so cool about using LayerZero here for this settle function here, that's what this line is, it means that the solver gets to pick when they want to rebalance. So if a solver's got a lot of inventory on both chains, it means the solver can say, I filled an order for $100, but it would be really inefficient for me to settle this right now. I'm going to fill 100 orders and then pack those all into one LayerZero message and send those all at one time to the other chain to rebalance. So it kind of gives more power to the solvers across the entire flow of a transaction.
And so in this model, the cost of the underlying settlement is amortized across all transactions, but every solver is constrained by system latency.
Exactly.
It's not dynamic. And this latency is up to the solver, and they get to choose whether to amortize it over a small number or a large number of transactions.
Exactly.
What the LayerZero cost is of settlement. Where like talk through a little bit of the architecture here. I'm not sure how technical we're supposed to.
Yeah.
I'm gonna dive into it anyways. Talk through a little bit of the architecture of like orders, like for 100 milliseconds. Is this order being like it's 100 milliseconds post finality of this block, basically?
So when I say the 100 milliseconds number, what happens is the user calls a smart contract function on the first chain. This is a basic deposit. You've done it a million times into any vault you've ever used. So the user hits a deposit, and then once that deposit clears, so the 100 milliseconds is from the end of the block on chain A. So the second this block is indexed by the solver then immediately routes that trade back to the destination chain and says, alrighty, I'm going to fill this trade right now by calling the fill function on chain B. Once they call the fill on chain B, the user has their tokens in the mempool already, and once that block ends, tokens are in the user's wallet. So when I say 100 milliseconds, I mean from the time of this ending to it being a transaction in the mempool on the second chain.
All right, so you have block time here. I'm going to call that, I guess, block time sub 0. This is block time sub 1 because, and let's just say this is Ethereum. So this is a 15-second block time. And this is base. So this is like a 200 millisecond.
Base is 1 second. Yeah, our Arbitrum is 200 milliseconds. Arbitrum is about 200, 250. Yeah.
And so this block, you just put in like a normal block. Any user, you submit your transaction goes into block, it gets finalized. That's, maybe you got in at the end of the block and it's only taking 1 second. If you're in the beginning, it takes 15 seconds. This block happens. Now there's plus 100 milliseconds here. And then this block is happening. And so this block you can...
Let's assume you caught the middle of the second block.
So if you catch the middle of the second, then you have an additional 100 milliseconds, which means the time from this finalizing to the user having the payout is 200 milliseconds.
Exactly right. Yeah, that's the exact calculation for how an intent is solved on Aori and kind of what the time it takes. And then what's so nice is a solver can fill 100 of these orders between these two chains and then just call the settle function one time. It sends all of their transactions, and because like LayerZero messages are so flexible in terms of how much data you can pass through, we estimate right now that a solver can settle 350 transactions in one settle call for, I think it's whatever the base gas cost of both chains is. It's incredibly efficient.
Which too is like extremely cheap.
Exactly.
Depending on where you're going, it's.
Yeah, it might be 1 cent for the solver to actually settle. Yeah. We ran one test just for some cool clarity here. We'll be open sourcing this test that people can do as well. We ran a test where we did a deposit, we awaited, we filled, and we settled with the LayerZero message, completely end-to-end, a full flow. The entire thing, I'm talking, from where we are right now to the Arbitrum sequencer to the base sequencer, that entire life cycle of a transaction took 5 seconds.
And so for comparison here, even in the optimistic case, you're talking 3 seconds in the most optimistic plus 90 minutes on the other end. Right?
Exactly right.
Something like that.
Yeah. And like the ultimate, anytime you look at any capital market whatsoever, whether it's in traditional finance, it's in crypto, it doesn't matter. For a solver is effectively a market maker. And that means that everything about their pricing is about how fast they can hedge and how fast they can get their inventory back to where they want it to be. And so the more time you cut there, the better the price they're able to provide you. So we expect solvers on Aori to be able to provide prices better than any other platform in crypto. So very, very excited about that.
All right. Amazing. Awesome. Thank you so much.
Yeah. Thanks, Brian. It was an absolute pleasure. Thank you.